Saxon's Calculus Lesson 23 is about logarithms of products and quotients, logarithms of powers, and then exponential equations. Now, logarithms of products and quotients. We've already reviewed logs and rearranging them to their exponent formats, but we've not reviewed all of the log rules, but you should remember them. We have reviewed if you have a number in front of the log statement, it's really the exponent to whatever is here. But we didn't review the others, I don't recall. Anyway, if you have two log statements that are adding, what you're really doing is multiplying their numbers. So in this case, x and y. If you are subtracting between log statements, you are dividing. And like I said, you should remember those. And those are the three log rules. So in example 1, it gives us log base 4 x plus 2 plus log base 4 of 5 equals 2. So I need to first recognize that all the parts, or both in this case, have the log 4. Now I realize that the 2 does not, so we're going to come back to that problem in a second. But a log base 4 is adding with another log base 4. So addition is really multiply. So we're going to do x plus 2 times the 5, and then that will equal, and now at this point I'm going to fix. So this should have had a log statement for me to be able to follow the log rules, and it doesn't. So this is being treated as multiplying with a log. So, oh, I'm saying that backwards. This is acting as the exponent to whatever this base is. So this is really 4 squared, which means that it equals 16. So now we distribute out, we get 5x plus 10 equals 16. 5x equals minus 10, 6. X equals divide 6/5. And we have solved it. Now remember, with log statements, you need to do a quick mental check that no negatives have occurred that would throw this answer out. 6/5 plus 2, not a negative, and nothing to plug in here, so we're good. Example 2. Natural log of x minus 1 minus natural log of x plus 2 equals natural log of 14. So I first check natural log, natural log, natural log. Okay, great. I don't have anybody missing what it needs, so we're going to follow the log rules. X minus 1, instead of minus, it's divide. X plus 2 equals the 14. Now it's just algebra solving. So this needs to move over to here by multiplying. X minus 1 equals, and I'm going to go ahead and distribute 14x plus 28. Then let's move this x over. So 13x equals, and then I'll move my 28 over, so negative 29. X equals negative 29 divided by the 13. And I need to check negative, okay, so let me kind of put this in its other format. Negative 2, that would be 26 and 3/13, so a little over negative 2. Negative 2 and an that's overall a negative. I can't have that. This answer does not work because it just created a negative with my natural log. So I have to switch this to saying there is no solution. Or again, I sometimes do the 0 with the slash through it, the null set. It should be through both sides there. Now, part B, logarithms of powers. Now, I just reviewed at the beginning, if something is multiplying, it becomes the exponent. That's what they're talking about here. So 2, make sure we're back on track here. Maybe like that. So 2 log 8x plus log 8/4 equals 1. So I attempt to do, well, I check to see, log, gotta fix it. So this makes it 8 to the first power, so basically 8. Now this 2 is gonna become the exponent over here, so I have x squared. The plus means I'm multiplying with the 4, and the whole thing will then equal the 8. So we have now 4x squared equals 8. So we're going to divide by 4 to get x squared alone. 8 divided by 4 is 2. And then I'm square rooting. So x equals both a positive and a negative, because I was square rooting, the root 2. And I check my answers. As soon as I check negative root 2 in here, I've created a negative sitting beside a log. It's a problem. So the negative one won't stay. Now I do need to check the positive one. Positive, oh, none of those matter. Yes, this one is then acceptable to be an answer. Now example 4, solve negative 2 natural log of 3 minus natural log x minus 1 equals negative natural log 1/4. Do they all have natural logs? Yes. Okay, so nothing to affix there. Then this negative 2 is multiplying, so it becomes the exponent, 3 to the negative 2. The minus sign means it's dividing, x minus 1, and it equals, the negative becomes the exponent, so 1/4 to the negative first exponent. So many choices. I don't like my negative exponents. I think I'm going to fix those first. So that's going to move this whole term down to the bottom, so it's no longer negative. So there's nothing in the numerator. I have to put a placeholder of 1. And then we still had this x minus 1 unit, and now we've moved 3 squared down and made that 9, equals, and the same thing is happening here. The whole thing 1/4 had the exponent that was negative. So we flip both, which makes it 4 to the first. 4 over 1, still 4. All right, 4 to the first. Now, I want to get this denominator out by multiplying it over here. That's going to give me 4 times x minus 1 to the 9th power equals 1. I feel like there might have been a simpler way, because I certainly don't want to do x minus 1 to the 9th power. Let me pause this and find where I've made it. I can do it more simply. Yep, found it. So when I wrote this, I wrote that as an exponent of 9. It's not, it's multiplying with 9. So when I move this over here, it should be 4 times 9 is 36 with the x minus 1 equals the 1. Okay, now it's fixed. Distribute 36 times x, 36 times the negative 1. Then solving, add 36 to the other side. That's going to give me negative 35 divided by 36. Oh, foo. They have it going the other direction. They have 37 over 36, which meant they didn't. Oh, good gravy. Add 36. It's no longer negative. Yes, that is 37. My, where is my head today? 37, yes, divide by the 36. X equals 37 over 36. I can't simplify any part of that, so there is that answer. Now, part C, exponential equations. Okay, so they give us 8 to the 3x plus 2 equals 16. All right, so the first thing that I see is I have a problem with my bases. This one's an 8, this one's a 16. I can't really solve this problem unless they share the same base. Is it possible to write them with a shared base? Well, yes, 2 cubed, 2 times 2 times 2 is 8, and then that is still having this 3x plus 2, so one base with 2 different exponents should multiply together. So I'm just going to write that with the parenthesis to indicate multiply. And then 16, 2 times 2 is 4, times 2 is 8, times 2 again is 16. Oh, good, that's 2 to the 4th power. Now that they have the same base, I don't need to look at the 2's. I just want to solve this part equals 4. So distributing, 3 times 3 is 9x plus 3 times 2 is 6 equals the 4. 9x equals, see if I can do this without an error, minus 6 should be negative 2, divide negative 2 ninths. Yes, okay, did that one without an issue. Now we need to move on to example 6. All right, and that is 10 to the negative 2x plus 2 equals 8. I have the same problem. My bases, one is 10, one is 8. But I cannot write 10 as a 2 to a certain power. So now I feel like I'm stuck. However, if you remember from trig class, we dealt with this. And what we did was we looked and we said, should we log both sides to force them to have a base of 10? Or should we natural log both sides to force them to have a base of e? Well, since this one is in a 10, let's log both sides. So when I log this one, it ends up canceling off the 10, and I just keep the negative 2x plus 2. But over here, this log of 8 turns into a decimal, which is 0.903. They keep going, but I'm just going to use 903. Then we're going to solve algebraically. So negative 2x equals minus the 2. That's going to turn that into negative something. Negative 1.0. I'm going to have to carry it out another place here. 97 to round off. Otherwise, I'm going to have it as negative 1.1, and I feel like I'm rounding it off a little too much. Then divide by the negative 2. Negative and negative is going to make a positive. 1.097 divided by 2 should give me somewhere around 0.54. They said 85. Somewhere in that ballpark, round 2 places, round 3 places, whatever. Example 7. E to the negative 2x plus 3 equals 5. Again, I have the same problem, e and 5. So this time I know that I'm going to natural log both sides to force the bases to be the same. The natural log and the e are going to drop off, just leaving me the exponent, and then the natural log of 5 is turning into a decimal, 1.609. Again, solve algebraically, minus the 3, that's going to be negative 1.39. Divide by the negative 2, it's going to be positive 0.695. I'll round it to 3 places this time. And then example 8, solve 5 to the 2x minus 1 equals 6 to the x minus 2. Now we're back to bases that can't be turned into the same. So I have to either log or natural log. It doesn't really matter. Typically we log first, but you can do whatever. So now log of 5 is going to turn into a decimal 0.699 for round it. And that's going to multiply with the 2x minus 1 that the exponent was equals, and then I'll have a decimal from log of 6, which is 0.778, multiplying with the x minus 2, and then distributing. So this times 2, this times the negative 1. Because this is all in decimals, and I can't do them in my head, and I've rounded off differently than the book, you know how to solve algebraically at this point. I'm going to jump down to their answer and tell you that they got negative 1.39, but you're basically distributing and then putting the x terms together, the non-x terms on the other side, and then finally doing that divide. Don't think you should have any trouble in those steps. And that was the last example.